8-7 is solving conic sections. Now, interesting thing here, in my opinion, this should be split up in two sections. Because one of them is solving conic sections by algebraically, and if you've done it, you've seen that. No problem. The other part, those are cool water bottles. It's just loud. I go coffee, something like that. The solving algebraically should be a different section than graphing inequalities, but they're not. They're both in the same one. So we'll do both of them today, both types of things. Okay. And you will see both of them on the test, so hopefully this will be useful for you today. Okay. If you're comfortable with it and feel like you understand them, great, this will be a nice review. Okay, now, solving conic sections. First, remember when we solve, sections was the wrong word. I got ahead of myself. It should be systems, because I want to use the word. When we did systems of equations before, what you were doing was we had a line and another line, and that point was the solution. The point where they met was the solution. The concept here is exactly the same, except now what we have is something like an ellipse with a line going through it. So now there's two solutions there. The 2 points where they meet are the solutions for that. Or you could have a hyperbola with a parabola, and this would mean 4 places where they meet. And that means you have 4 solutions, and you have to give me all 4 solutions. Okay? And sometimes you don't have it like that, because you could have like an ellipse, and you could have a parabola that meets it in only one place, like this. And so even though it looks like, you know, if the parabola was moved up some, you'd have 2 or 4 solutions, it might only be 1. You don't know until you solve it. So you could graph it, but algebraically is actually usually a little easier sometimes, because you graph it, you can't always tell the exact point. You're sometimes having to guess if it's a decimal. You can do a square root for an exact answer. But I'm going to make you do some algebraically. And then when we do them where it's shading, it would be something like this, where maybe this one would be shaded on the inside, and this would be shaded this way. So this part would be the part where they overlap, and that would be the solution. And so we're just going to do the same thing with inequalities. So I guess the two go together. I just think they should have made them separate sections. Anyway, that's my thing. So let's start off with solving one like this. We're going to solve y equals x squared minus 2x minus 15, and x plus y equals -3. So you can see that's a parabola because it's a squared, 1x squared, and there's no y squared. Okay, so we've got x squared. This one is nothing squared, so that's just a straight line. So we have something that could look like this with a line going through it. So that's like 2 points there. It could be, the parabola is positive, so you know it's going up. This line could be like over here, so it could be no solutions. There might not be anything. Or it might just touch it at one place, and there might be just one. Don't know. It might be going like this. Line might be going like that, and there might be only one solution. We just don't know yet. So we're going to find out. We're going to find out algebraically. Because if you look at this now, you could do any of the techniques that you learned with systems of equations. Graphing it is one. That is a possible thing, except I'm going to make you do it algebraically. I'll probably write on a couple of them, solve algebraically, because I want to see you can do the equations. You can do the substitution or the elimination method. And usually when you have squares, the substitution method is really hard because you've got to take the square root of something, except this one doesn't have any squares. So this one, substitution, is a method that would probably work a little easier. So what I'm going to do here, I could either subtract x or subtract y, but I'm thinking if I put in here either x or y, what I'm going to do, well, let's try something. If I subtract y from both sides, I get x equals -y minus 3. If I subtract x from both sides, I get y equals -x minus 3. If I use this one, I have to take this and put it inside here and then square it. Nothing wrong with doing that. Perfectly fine thing to do. Just seems easier to me that if I do this one, then I can take -x minus 3 and put it here. here, and I'm still going to have to work with a square, but to me that's a little easier. I'm not going to have to like square it out, multiply it out. So I'm going to use this, and that's going to be that y. In fact, think about this. Y is equal to this, y is equal to this, y is equal to y, right? That's the point of this, is that the x and y, the point we're looking for, all the points we're looking for, the y is the same for both, for each of those points. So if y is equal to y, then negative x minus 3 is equal to x squared minus 2x minus 15. Now, one of the issues sometimes on the last test that sometimes people had is when you get something with a square, people didn't automatically think of factoring. What they tried doing in many cases was trying to move things to one side, take out a common factor, which isn't a bad thing, take the square root of both sides. Almost always the easiest thing to do is to factor if you can, which means put everything on one side, get it equal to 0. Okay? That's a technique, a habit I want you to think about getting into. Get it as to 0. Don't try to get, let's say, if we bring the 15 over, we get a 12, we'll bring the x over, and then you try to take the square root of both sides. It's mathematically possible, but you just turn a problem that's a 4-step problem into like a 12-step problem. Okay, and that's a big difference. So I'm going to move these over here by adding x to both sides. So x squared, so plus x and plus x makes this a negative x. Plus 3 and plus 3 makes that a negative 12. So I now have 0 equals x squared minus x minus 12. You learned factoring before for a reason. We did this month 1 and you learned it in integrated 2 so that you could say this, if it's possible. I mean here, and the other thing too is if this couldn't be factored, I'd go to the quadratic formula. In other words, try to do the thing where x squared, let's see, minus x is equal to, let's see, that would have been a 12 on the other side. And then this is what people try to do in some cases in the last test, and then at that point they've got a real mess. Because you can't really, they would try to take the square root of both sides, except you can't do that when you have 2 x's. Well, you can, but you're going to have, you'd have to move the x over here and have the square root of that. In other words, it becomes a real mess. Just don't do it. Okay, do it this way. I mean, there is a mathematical way to work it out, but it's extremely complicated. It's just not worth your time. Do it this way. Factor it. Use the quadratic formula if you can't figure out how it factors. But in this case, negative 12 is a 6 and a 2, or a 4 and a 3, or a 12 and a 1. But 4 and 3 would work there with a negative 4 and a positive 3. So that means we have 2 x's that would make it 0. X is equal to 4, x is equal to negative 3. So we have 2 x's. Now figure out the y's. Okay, so we're going to put 4 in over here. So it looks like if I put a 4 in here, x plus y equals negative 3. 4 plus y equals negative 3. Y is equal to negative 7. Subtract 4 from both sides. X plus y is equal to negative 3. If I put negative 3 here, it looks like y is equal to 0. So for this one, I get a 0, and for this one, I get a negative 7. So it looks to me like one answer is a 4, negative 7. The other answer is negative 3, 0. And there's 2 answers because now if I graphed it, you don't have to graph it, but I'm going to go over it. 4, negative 7 is like down here. Negative 3, 0 is here. So there's where the straight line must go through. And the parabola, let's see, negative b, the x, the vertex is negative b over 2a, negative 2 over 2, that's a negative 1. So, let's see, I think it's probably down about here. So we are somewhere like about here. This is approximately what that graph looks like, just give or take approximately. And I can tell it now from graphing it because I can see those 2 points, but I need those points. All right, so let's think about what I did here, and you'll replicate it. We'll replicate it in another problem in a moment. This one I did by substitution because it lent itself to substitution. This makes substitution easier. If I wanted to do it by elimination, that would be pretty hard to do. I'd have to multiply everything by an x or a y. I'd have to get rid of the, I guess I could do it with just the y. So I could subtract y on both sides. That would work too. And we'll do elimination on the next one. But it looked easier for me to do substitution, so I did that, and it gave me that, and then you just calculate it and factor it. And remember that you have to get separate answers for both of those. Okay, next problem. Let's go to this one. Yeah. I wanted to do. Okay, this will be an interesting one to look at. X squared minus 4y squared is equal to 4. X squared plus y squared is equal to 4. Well, I can tell that this one's a hyperbola because one of the squares is negative. And this one is a circle because it's 1 and 1, they are the same thing. So we have a hyperbola and we have a circle. So I don't know how that's going to work out. It could be that the hyperbola is here and the circle is here, so we have 2. The circle could be bigger and we could have 4. I don't know what it's going to look like. It could be lots of possibilities. It could be the circle and the hyperbola like touching it in 2 spots or something like that. Don't know. Some interesting car logo type of thing. Because you notice, you look at car logos, some of them actually are conic sections. I think it's Toyota that uses a like an ellipse or something like that too. So here, I could actually do this with substitution, with the y squared over and plug it in there. That would work too. What I'm going to do though, I see 2 x's here, I'm just going to subtract. I'm going to eliminate. I'm going to do addition or subtraction of the equations because it's set up easily for me to do x squared minus x squared. There's no more x squareds, and there's no other x's either. All x's are gone. All I have to now work with now are y's. So I'm going to have negative 4y squared minus y squared, and 4 take away 4 is 0. Ooh, interesting. That gives me negative 5y squared is equal to 0. Okay? And usually I'd say multiply everything by a negative if you have a negative for the main number, which I'm going to do because I have negative 5. Let's just divide by negative 5. Y squared is equal to 0. And square root of both sides means y is equal to 0. But that's y squared is equal to 0. So in a way you have 2 zeros. So we're going to put zeros back in both because we're going to get 2 answers. Well, actually it won't matter. Let's see what happens here. So it doesn't matter which one I use because if I put 0 here, I'm going to get x squared is 4. If I put 0 here, I'm going to get x squared is 4. So x squared equals 4. Take the square root. Don't forget that when you take the square root of a number, you have to do plus and minus. That's how you get 2 answers from this. Okay? That's another don't forget thing. If you forget that on a test, you just let half credit because you don't have half the answers. Okay? So it's just to remember. Remember. Okay? Because to get 4, you could have minus negative 2 times negative 2. So you have to account for that negative, not just the positive. Okay? So that means that 0 for, 0 is a y. So the positive 2 has 0 as a y, and the negative 2 has 0 for a y. So we have 2 answers for it. Okay. So that means most likely if I were to graph it, negative 2, positive 2 are both here. And so most likely this is the circle, and most likely this is the parabola like this. So just a guess, that's probably what it is if I were to work it out. Okay. But what I'm looking for are those. Okay. Okay, now let's bring it up a step. I'm going to do another similar one. In fact, this will be a circle and a parabola. Okay, let's do this. Solve x squared plus y squared equals 9. X squared plus y is equal to 3. You can't get rid of the y's in this case, because you have a y squared and you have a y. You can't eliminate that. You could do a substitution. Y is equal to negative x squared plus 3 and plug that in there. So that's possible. You could do a substitution with the x squareds. But this is like the other one where it looks like subtracting it will make this easier, because the x squareds go away. And you notice I sort of talked that through a little bit. Whenever you look at these, the first thing you want to think about is, based on what it looks like, what can I do to get rid of something? Which ones? What choices do I have? And you have choices. If you prefer to do this as a substitution, I'm not going to stop you. It just makes it a little harder. But if you get it right, you get it right. I'm fine with that. But that's the point, is I want you to look at and analyze and think, what's the method I could use, which way? You see both of them are x squareds, and you realize, oh, I can subtract them. At least that's how I'm thinking. So I'm going to do it that way. X squared take away x squared, those are gone. Y squared minus y, and 9 take away 3. And this again is a reminder, put them on the same side. Don't play with this where you try to like, I don't know, people were doing weird things on the test room sometimes, a few people, but not most people, most of you are good at those. So I'm going to subtract 6 from both sides. Oh, well, that looks pretty similar. It's just like with the x's. So in this case, we have a -4 and a positive 3 again. Y minus 4, y plus 3. That was unintentional to have the same factoring one, but okay, so, oh, wait a minute, no, it's not, it's 2. Oh, it's 2 and 3, that's my mistake. Minus 3, because they get that 12 one, so it's different. So, good thing I look back, because whenever I do these, I always check, the easiest check is, when you multiply the two numbers, do you get the C back here? And I realized, ooh, it didn't, so I caught myself before anybody else could say anything. -3 times positive 2 gives me the -6. And -3 plus positive 2 plus 2 gives me a -1 for the coefficient here. So that means y is equal to 3 and -2. We got opposite signs. Now, I will say, let's see, I've had people who say, let's say that they could, complete the square. Let me just show you. You could do this, but it's going to take more steps. Let's play with this idea. If I do y squared minus y and equal to 6, I can get the perfect number here to get a perfect square. Okay, now, I'm going to do that, but I'm going to show you how you get the right answer. Just, to me, this seems a lot easier. So right now, this is a -1, so c is equal to -1 over 2 squared. Okay, so that's going to be 1/4. So that means I'm adding 1/4 here, and I'm adding 1/4 here. So I get y squared minus y plus 1/4 is equal to 6 1/4. This is a perfect square of y minus 1/2 squared is equal to 6.25, let's call it. But that's better if you write it as a fraction, 25 over 4. Now you can take the square root of both sides. Y minus 1/2 is equal to 5 over 2, and a plus or a minus. Now you can do 5 over 2 minus 1/2 and -5 over 2 minus 1/2. So here you get negative, let's see, minus, oh, that's 4, let's see, -3. Oh, I'm getting a -3. I'm getting a positive 2 and a -3, but it's supposed to be the opposite. So let me check what I have off on numbers here. Oh, nope, you know what I did? The -1/2 comes over and it's plus them both. So this is a 3 and that's a -2. So see, it's just too easy to make mistakes with this. So I get the same answer as 3 and -2. When you look at it, this is why you're factoring. If you know you're factoring, life's a lot easier by knowing factoring. So doing another method, this one where you complete the square and then take the square root, and I know some people like to do that, you're welcome to try to do that method. But it's a good deal longer and a good deal more places where there's possibility for errors. So remember that about the different methods and things you can do, is think about what's going to help you the most to get it right, both remembering and making it easier on yourself. Okay, back to here. We know this. So let's first use y equals 3 and plug it into one of these. Well, that's easier here. X squared plus 3 is equal to 3. X squared is equal to 0. Oh, so that means x is equal to 0. So 3 and 0 is one answer. Now, if I put -2 in here, x squared, now I'll do the y equals -2. X,
There should be 0, 3.
oh, yes, it should. You're right. Thank you. Okay, now we got it. Now, here, y is -2. I'm going to put it into here. X squared minus 2 is equal to 3. Add the 2's. X squared is equal to 5. Take the square root, so x is equal to plus or minus square root of 5. So now I have the square root of 5 and -2, and I have the square root of 5 and negative square root of 5 and negative 2. And you can make this as decimals, because if I don't tell you, you can't, because graphing this is really hard to do. If you were going to graph it, rounds to about 2.2 and negative 2.2. But you can leave the answer as square roots. But notice now we have 3 answers. This one needed 3 answers. And you don't know that until you get down to it. If you graphed it, you can use a graphing calculator. Well, these are very hard to put on the graphing calculator, because you have to make it y equals. You have to deal with the square roots and do 2 separate equations for each one. So I'm not going to recommend it there. But you graph it by hand, and you can see there's going to be 3 places where it meets. Okay? And I forgot, I think I graphed this once, but I don't have it here. But right now, then, you can see actually.